Good day, everyone. Welcome to my talk on who broke the build using Kuttl to improve end-to-end testing and release faster. No one wants to be responsible for breaking the build, but what can you as a developer to avoid being the bad guy? How can project leads enable their teams to reduce the occurrence of broken builds? Have you ever seen such kind of scenario in your company where manager asks who has actually broken the build? He's a little furious. Uh, But the developer would say that I don't know who has actually broken the build, but I will find out. I'm not sure if I could have myself broken the build, or let me check with the team and come back. Okay, a quick introduction about myself. I'm Mohan Rao Chukka, Senior Software Engineer R&D, India, Bangalore. I'm passionate about open source. I love playing table tennis. I can be reachable on both LinkedIn or on Twitter, or newly called X, at ichuka.ichuka. Let me do a quick introduction of my company so that you would understand the scenario much better. JFrog was founded in 2008. It's a publicly listed company, around 1100 plus employees and growing, and in 9 locations, headquartered in Netanya. We have around 7,000 plus, nearly 8,000 customers. And most of these customers are Fortune 100 companies. And out of those Fortune 100 companies, 70% of them are our customers. We have around 6 to expanding products. Almost all the products are hybrid. And we have an universal DevOps platform. And more importantly, we contribute to the community. So does software upgrades matter? In the current world, software is run on everywhere. It is used in healthcare, politics, social interaction like Twitter or any other, food and water, transportation and energy. Do really software updates really matter? Yes. Every company is a software company, and the quality of the software part of your company or the product is giving you a differentiator. So let's take a quick example how software upgrades actually really matter. So you can think of, you have a Tesla model and you would like to do an upgrade. It clearly says in the instructions saying that when you do an upgrade, during the upgrade, you will not be able to drive your vehicle. So you would be actually struck not driving a vehicle when a software upgrade is happening. So to summarize that, JFrog mission is to power all the software upgrades in the world. JFrog mission and the goal has always been to help customers deliver upgrades faster, quicker, so that to move the speed of the business. So we have large number of enterprises using our software, primarily into internet and software technology companies like LinkedIn, banking and finance, and you name it, we have it. And we actually work with the open source cloud vendors as well as AWS, Azure, Google Cloud, IBM Cloud, and all the logos that you see. So let us switch back to the context of my talk. So lastly, around a decade back, people used to follow a waterfall model where they used to have the requirements freezed, then go with an architecture and a design, then a development, post that a QA and a release and post production and maintenance, which would almost take an year or a two to complete the entire features release to the customers. Then we had something like an agile model where you do the design requirements and probably do a rollout to production within a couple of weeks or so. And there was a new model that evolved. it's more like dev and operations collaborated with each other to release faster. It's more like an agile way, fast forward, where if needed, releases can be done multiple times in a day. Okay. So DevOps actually means it's a collaboration between both devs and operation working in silos to give a desired output for the customers to release much stable updates to the product or the software upgrades, which would mean we have actually moved from a waterfall model from an yearly or a monthly release to a daily release cycle in DevOps. Let's start with the agenda of my talk. Just an overview of what I would cover in this session. I would first start with what an ideal development environment would look like. And this is more to do with developer productivity. In this session, I will cover a quick history of our testing challenges and what led us to Kuttl, and the benefits of our new testing approach, which is easy to configure and a minimal investment, and how we combine Kuttl and CI pipelines for a more streamlined and few broken builds. So we were evaluating a couple of tools. How can we leverage probably local testing on our dev environments where developers don't need to actually look up for a remote CI/CD to run their test. So let's walk through each one of them and see how our testing challenges and what led us to Kuttl. Just an overview of how a ideal development environment would look like. It's more like a single click setup where everything is automated. You develop and test locally. And more importantly, it's same as production environment, which is to reproduce the production issues on local environments to release. I mean, if you can debug the issues, you can release faster, fix it and release faster. So say, for example, a developer joins a new team. As part of his onboarding process, he would be given a manual steps to look up to a wiki page, do all the installations based on the setup, which would actually take probably a couple of days to set up his environment or a day or two to set up his environment. But using automation, you can actually have some scripts written or some modules that you can just run it so that the development environment is set up within minutes, which would mean instead of taking hours or days, you can actually set up the environment using some automation within minutes, which also means no manual steps implies error-free, and also more importantly, quick reload. When you can actually develop everything locally, you can actually deploy, test it locally. So the reload cycle is much faster. And as I previously said, dev environment should be as same as production environment. This helps to save us time and to reproduce production issues at ease. Okay, let's come to the main problem that most of our developers face. So when you take a feature branch development, developer works on a feature. He writes some unit test based on the feature developed, then writes some tests, which may be unit tests, and then commits and pushes to a Git remote repository. Ideally, when most of the scenarios, what we have seen is these end-to-end tests are very difficult to set up, and most of the developers don't write end-to-end tests. And these tests are actually executed on a remote CI/CD server. So the problem that when a pull request is raised or a merge request is raised, since these end-to-end tests are executed in a remote CI server, say for example, when I raise a PR, test run for a couple of hours, maybe more than that. Then if a test fails, I need to come back and understand the logs on the remote CI/CD server to look up what has failed Then if I identify the issue, then I would be able to fix it and commit again. So this round trip of fixing an issue is huge. So instead of, is there any better way to actually avoid running these end-to-end tests on a remote server? So we had an idea how uh, these end-to-end tests can be leveraged on a local environment. So let me quickly go walk through the remote end-to-end test with a pictorial depiction. So when a developer writes code, he writes the unit test. If something passes, then he would raise a pull request or a merge request on a remote CI/CD server. The test run, if it fails, the round cycle actually continues until a merge request. After a successful end-to-end test are run with a code review, you would be able to do a merge. But is there any alternative for this problem that most developers face not running end-to-end test locally? So we had an idea how can we leverage these end-to-end tests locally. Instead of running these remote end-to-end tests, use local end-to-end tests, which are exactly similar to how these tests run on a remote CI/CD server, which would mean exact replica of testing on a production instance or some environment very similar in a dev environment, which would mean you don't need to push your changes directly to a Git branch. You can just locally commit or have it in a feature branch, test it, and then run that. What what it would mean is instead of pushing the changes, since the environment is entirely local, you would run it. If tests fail, and if you have a good uh, configuration of the system, these end-to-end tests would run much faster, and you would be able to fix them locally, test it. If everything works, then you can raise a pull request or a merge request. So let me quickly give you an example or a pictorial depiction of it. So what we are saying is, instead of running these end-to-end tests remotely, move this end-to-end test locally, set up an infrastructure very similar to having a dev environment, which would set up your end-to-end environment, run those tests, and see everything works. So while we were evaluating how we can run these end-to-end tests locally, we were fortunate to look out for some open source tool, and we identified a tool called Kuttl. So in talking to our teams, we discovered that most developers weren't running sufficient integration and end-to-end test in their local environments because it's too difficult to set up and administer test environments in an efficient way. So that's why we decided to rethink our entire local testing in hopes of cutting down the headaches of valuable time wasted. So we discovered a tool called Kuttl. Connecting Kuttl to our CI builds has empowered our developers to easily configure a dev environment locally, which accurately matches the final test environment where you run the end-to-end test. So let me give you a quick overview of Kuttl. Then I would give you a quick demo how Kuttl can be tested. Using Kuttl, you can run end-to-end test locally. So Kuttl is a Kubernetes test tool. It is a toolkit for writing tests, mainly designed for testing operators. I know testing Kubernetes operators is not easy. The motivation here is to leverage the existing Kubernetes ecosystem for a resource management way of doing a setup and easily asserting state within the cluster. So what I mean by that is, instead of writing a Go code or a Java code to get the current status of a Kubernetes cluster to do an assertion, do a YAML-based declarative way of testing it. So Kuttl provides a YAML-based declarative way of doing testing, which would mean you don't need to learn a new language, even if you are not comfortable with a Java or a Go. You can still write these end-to-end tests using a YAML-based approach, which is very easy. I would explain the different steps in the subsequent slides, which would mean it also accelerates the ability to create the end-to-end testing environment. So let's get started with how can I install Kuttl. If you are a Mac user, you can use a brew tab, Kudo Builder tab. So Kuttl is actually a part of Kudo Builder. Kudo Builder was CNCF project for developing operators, and they developed a tool called Kuttl for testing the operators in a declarative way. If you are a Linux user, you can use Kuttl crew, install kubectl crew, install Kuttl. If you are a Go developer, you can still do an API integration with your code, very similar to how Selenium or can be done in Java. So go get GitHub Kudo Builder Kuttl. Crew is a kubectl packet manager. Kuttl is both CLI tool as well as an API for testing. So Kuttl is for if you are a developer who wants to test operators or any Kubernetes resources for that matter, without writing any Go code. And if you want to test Kubernetes applications in different versions, Kuttl would provide a framework that is very easy to create and execute as well. And if you are an application admin, if you want to operate the creation of a Kubernetes cluster, you can use Ansible as well. But Kuttl also provides a cloud native way of doing testing. So let me first start with three main parts of Kuttl. First is a test suite. Test suite, you can see line number 2 there, kind test suite, and with an API version defined as Kuttl dev v1 beta 1. This is actually a CRD, custom resource definition. And you can see line number 3, start kind as false, which would mean if you don't provide any Kubernetes cluster, you can use the existing cluster as well. If you want to use the local kind is also a Kubernetes cluster, which you can spin up using Docker desktop. So for my demo, I would be using the start kind as true. So I don't want to use any external GCP or Azure or any external AWS clusters. I would like to demo entire thing on my local environment. So I would be using a Docker desktop. The prerequisite for this demo or using Kuttl in conjunction with kind is to have a Docker desktop. And the name is the end-to-end test that I've just given it. Next is the test directories where you want to run these tests. And the commands, you can see, I would explain each one of them. So test suite is a collection of tests. And there is a YAML file called test suite configuration file where this is actually defined, how the suite would look like. And line number 11, you can see a timeout of 300 seconds. Say that the test suite runs more than 300 seconds, which would mean the test would actually fail, suite would fail with an error saying that it is a timeout. So you can have a timeout on running those test suites as well. The first step is a test suite. Next is a test step where you define kind as a test step. This is also a CRD, and where you execute commands. So it's more like if you have a bash script or if you have anything, you can directly use a for my example, I would cite with installing Artifactory, a stateful application, and to see the install went successfully while doing an assertion. So test is a step of collection of test steps. So you can have n number of test steps inside a test. I would cite with an example in my demo. Next is the assertion part. So once I do a test, I would like to do an assertion whether the test is successfully achieved. So this is where a declarative way of testing happens here, where you set, since it is an stateful set application, I would expect the default installation of Artifactory would come up with a single replica. And I would also test whether that replica is ready. Ready replicas is equals to 1. So the test route structure would something like that. So I have a demo application where I would have a test and add end-to-end test. I have 3 to 4 tests that I would run. So more importantly, Kuttl supports parallel execution of tests where you can run n number of tests parallelly, 8 in specific. So you can create a test suite with 8 tests and run all of them in parallel. So let me quickly walk through a demo. Let me share my terminal screen. Let me give you the structure. So I have 4 tests that I would like to run. So let me quickly open the test Kuttl test.yaml. So where you can see this is a test suite which I would be running, which would have 4 tests. So I'm doing a installation of Artifactory in 4 different tests. kubectl Kuttl test. Before I run, I would make sure that Docker is running, which is not in my case. So let me wait for Docker to come up. Okay, then I would run kubectl Kuttl test, which would run the entire suite. So what it would create is, since I've specified start kind as true, which would create a kind cluster, we can actually get the kubeconfig file and connect to that cluster as well. So let me do an export of this kubeconfig file. So I use an open source tool called K9s to view the Kubernetes clusters. You can do a brew install of this K9s. So what this Kuttl kubectl Kuttl test has done is it has executed the test suite, and you can see it has actually run the prerequisites commands as part of the test suite. So it has created a few. It has created a jfrog repository, Helm repo add, and then it has run 4 tests. You can see end-to-end test has 4 tests. So what it would do is it creates 4 namespaces and runs these install tests and then does the assertion of these tests. So which would probably take 5 to 10 minutes to run this test. So in the meantime, I would go back to the documentation and help you understand how Kuttl documentation is specified. Okay. So as I said, Kuttl is from Kudo Builder. It's a CNCF approved project. It has quite a good of maintainers. It's a declarative way of testing Kubernetes operators, but it can be used for any Kubernetes resources. So there is a specific Slack channel associated with this in Kubernetes Slack called Kudo. You can go and ask if you have any questions around that. And they have a good documentation how Kuttl would works. As I previously discussed, Kuttl has 3 things. One is test suite, test step assertion, and it has something called collectors and commands. You can go through the documentation. Some CLI usage, how Kuttl can be used. You can see brew install Kuttl. Then you would run kubectl Kuttl test, which would run the entire test suite. There are few examples how can you actually create your own test suite. Very simple. Go through the documentation, and if you have any questions, you can always reach out to a Slack channel at Kudo Slack. There are some tricks and things where when you want to load images. So when you want to load these images, say if you want to run these tests very frequently, you don't want these images or some images to be downloaded every time. So just to make sure that kind also provides loading images much faster. It's more like caching those images. Let's switch back to the demo where we are. Let's see how the installation would, let's check the installation part. So as I said, it has created 4 namespaces and it is trying to run the install of Artifactory. It's a stateful application and we will be doing assertion. So let me do a quick sit. So K9s is provides a UI way of managing the clusters. So you can see, so my assertion on these test cases is to have the stateful set application. The read replicas would be 1. So once every Artifactory starts up in each namespace, so see here, the Artifactory started in one of the namespaces. So once that assertion is completed, that namespace is actually got deleted by Kuttl. So it cleans up once the test is done. So once it runs 4 tests, it would also give out a report of what tests it has run, what tests have been successful, and what were the failures. So you can have a report format as XML or JSON, and which can be actually integrated with the CI pipeline to see how the test actually failed. And one more good thing about Kuttl is it provides detailed output logging onto the console. So you can see what actually has happened when the installation is doing it. So you can see, so once the test is actually done, it creates deletes the namespace. Okay. Let me switch back to the pods. So K9 provides a good way of switching to pods, replicas, deployments, and other aspects as well. It's very easy way and a convenient way of using of managing Kubernetes clusters. So you can see still few upgrade tests are running. We would wait for the final result, but you can also see. Let me see the logging, how the namespaces are getting created. So once it randomly creates a namespace and does an install command on top of it. So I'm running an install 01 Helm install of this application with some default parameters and a scale test. So if all these test output is actually provided in the console to see if something breaks. Say, for example, if a test breaks or test fails, you would get a detailed report why the test has failed. Say, for example, before I switch back to a failed example, I would just like to see the final report, how this test has actually failed. So it is actually deleting the final namespace of that test. So you can see it has run all the tests. All the tests have actually passed. Say, for example, if there is some failure due to some issue in our code, it would give a detailed report why it has failed. Say, for example, you have set the replica count as 2 instead of 1. So it would give an assertion saying that your test case has failed. Expected output is 1, but you have given as 2. So it gives a clear indication of why the test has actually failed. Hope this Kuttl can be given a simple example of an install test. It can be used for any API testing. Say, for example, if you want to test an endpoint where you can do a post request and get the response back, you can do an assertion on that response as well. So let me go back to the my presentation. So quick summary of references that what we have learned so far. Kuttl documentation is documented at kuttl-dev.docs. So the GitHub page is GitHub Kudo Builder Kuttl. And there is a Slack channel called Kudo. And another tool, that open source tool that we have used called K9s for managing the Kubernetes clusters. So let's have a quick summary of what we have learned so far. Kuttl is more importantly an open source tool. Anybody can contribute, and it's free to use. It can be used for local end-to-end testing. When you have local end-to-end testing and you are able to fix most of the issues locally, then which would mean few broken builds, which would also mean you could release much faster, which would eventually mean happy developers and happy customers eventually. If you have any questions, I'm freely available on LinkedIn or on Twitter with my hashtag iChukka. Thanks for joining my session.